Hello everyone. We are excited to present our work. SVG-Head. Hybrid Surface-Volumetric Gaussians for High-Fidelity Head Reconstruction and Real-Time Editing. This work has been accepted to ICCV 2025. This research is a collaboration between Tsinghua University and Tencent Hunyuan. 3D head reconstruction is a fundamental challenge in computer vision and graphics. It's the core technology behind many applications we see today, from creating digital avatars in gaming and movies, to enabling immersive experiences in virtual and augmented reality. However, existing methods have limitations. Traditional mesh-based approaches often struggle to represent complex volumetric areas like hair, and depend heavily on high-quality geometry and detailed UV maps. More recent approaches using NRF and 3D Gaussian splatting can capture incredibly realistic appearances, but they face a major challenge. Because they entangle geometry and texture, or use implicit representations, they are very difficult to edit in real time. Several recent works have TAC-led animatable avatars. For example, MEGA uses a hybrid mesh Gaussian approach, but relies on slow, optimization-based editing that can take several minutes. Gaussian avatar editor uses diffusion models for editing, but can struggle with fine-grained control and 3D consistency. The key problem of real-time texture editing remains unsolved. Our work aims to address these challenges with four main goals. First, to build high-quality 3D heads that can handle complex facial expressions and diverse poses. Second, to accurately reconstruct fine, non-Lambertian details like lips, hair, and the inside of the mouth. Third, to achieve real-time rendering and animation, and most importantly, to support real-time interactive appearance editing. To achieve these goals, we introduce SVG-Head, a novel hybrid representation. Our pipeline consists of two main stages. First, we perform surface Gaussian optimization. Here we bind surface Gaussians directly onto a flame mesh. These Gaussians sample their color from learnable texture images using Anival mesh-aware UV mapping technique. This stage gives us a coarse result with an explicit, editable texture. In the second stage, joint optimization, we introduce volumetric Gaussians around the mesh to capture complex details like hair and lips that the surface model can handle alone. We then optimize both types of Gaussians together to get our high-fidelity final rendering. A key component of our method is the mesh-aware Gaussian UV mapping. To get a sharp, editable texture, we need a consistent way to map any point on a Gaussian to the 2D texture space. We achieve this by projecting the intersection point of a view ray and Gaussian on to its corresponding mesh triangle. The UV coordinate is then calculated using barycentric interpolation from the mesh vertices predefined UVS. To make this process fast enough for real-time rendering, we pre-compute and compress this operation into an efficient affine transformation. Let's look at the results. In our quantitative comparisons, SVG-Head achieves the best metrics among all editable reconstruction methods. As you can see in the table, for both novel view and novel expression synthesis, our PSNR, SSIM, and LPIPS scores are highly competitive, even when compared to non-editable state-of-the-art methods like Gaussian avatars. Qualitatively, our method produces high-fidelity results. If we compare SVG-Head to other methods, you can see our reconstructions capture fine details and maintain a natural appearance, successfully avoiding the artifacts or blurriness present in some other approaches. But the real power of SVG-Head lies in its editing capabilities. Here we compare it with Mega and Gaussian avatar editor. Because we have a disentangled, explicit texture map, we can perform fine-grained edits, like drawing glasses or patterns, in real time. As you can see from the timestamps, our edits are instantaneous. In contrast, methods like Mega require a slow, predit optimization process that takes several minutes, and can sometimes produce unintended changes or misdetails. In summary, SVG-Head is a novel hybrid representation that combines surface and volumetric Gaussians to achieve high-fidelity reconstruction, animation, and for the first time, real-time interactive editing of head avatars. Thank you for watching.